Let us solve another question that was asked in JM Economics paper of 2022. The question is like this. Let the system of equations be alpha u plus w is equal to 0, u plus alpha v is equal to 0, and v plus alpha w is equal to 0. Where alpha belongs to real numbers, then the system has infinite solutions. If alpha is equal to, we have to find the value of alpha here, for which this system of equations has infinite solutions. Okay, so let us write these equations first. So we have alpha u, uh, plus, in place of v, I can write here 0v plus w is equal to 0. Okay, so 0 times v is 0, so we are left with alpha u plus w. Similarly, we have u here, u plus alpha v plus, in place of 0 I can write 0 times w is equal to 0. Similarly, we have last equation. So in place of, since we have no u in this equation, so in place of this I can write 0 times u plus v plus alpha w, okay, is equal to 0. So what will we do? We will write the system of equations in matrix form and use Cramer's rule in finding whether the value of alpha, so that this system of equation has infinite solutions. Okay, so writing them in matrix form means we write it like this: a x is equal to b. Okay, where this a is the coefficient matrix, so I will write here our a is equal to the coefficient of u, v and w. So here the coefficient of u is alpha, I can write here alpha. Here we have 1, the coefficient of u. Here we have 0. Okay, here we have the coefficient of v as 0. Here we have alpha. Here we have v, in place of v, the coefficient is 1. Okay, here the coefficient of w is 1. Here we have 0. Okay, this is our coefficient matrix. And what is our x? X is the solution vector. That means what we need to find u, v, w. Okay, u, v, w. And our b is the vector of constant terms. Okay, b is our vector of constant terms. Here we have 0, 0, 0. Okay, so first thing is to write the system of equations in matrix form. Now this system of equations will have infinite solution if, okay, if so I will write this system of equations have infinite solutions if the determinant of this coefficient matrix, that means if our the determinant of this coefficient matrix is equal to 0, and the other matrices, that means a1 is equal to a2 is equal to a3. If these are also equal to 0, then we say the system has infinite solutions. Okay, now what are these a1, a2 and a3? These are the matrices which are formed by replacing the column of this coefficient matrix with the vector of constant terms. Okay, so we don't need to find them here, but this is the condition for the infinite solutions. Okay, so if I have time, I will show you how do we get a1, a2 and a3. First, let us see, if determinant is equal to 0, then we will have infinite solutions. That means, so taking determinant of this matrix, that means first we have alpha, so I will write here alpha. Okay, now mentally deleting this row and this column and taking determinant of the remaining elements. That means alpha into alpha is alpha square, minus 1 into 0 is 0. Then we write minus times 0. Okay, so first we have plus, then minus, then plus. Okay, so this is from the formula. So now deleting this row and this column and taking determinant of remaining elements, that means 1, 0, 0 alpha. 1 into alpha is alpha, minus 0 into 0 is 0. Okay, then we have plus 1. Okay, now in this here what we need to do, we need to delete this row and this column and take the determinant of the remaining elements. That means 1 into 1 is 1, minus 0 into alpha is 0. Okay, actually I have explained this whole stuff in the matrices series, in a linear algebra series. You can find out how do we use the Cramer's rule or how to find the determinant. Okay, so this whole step should be equal to 0. Now here you can see we have alpha into alpha square. This means this is alpha cube. Okay, then since this 0 is multiplied to this term, this whole stuff will become 0. Here we have 1 into 1 is 1. That means alpha cube plus 1 should be equal to 0. Okay, that implies, so we have alpha cube plus 1 is equal to 0. We can write it like this, alpha plus 1, this is the formula. How do we write? Then we have alpha square minus alpha plus 1 should be equal to 0. Okay, I am just expanding this here because we have a cube, or I can write it like this, x cube plus 1 is always equal to x plus 1. This is the formula which I guess you know. This is the basic formula. So this is equal to x square minus x plus 1. Okay, so this straightforward comes from the formula, okay, from the factorization. So here either this stuff is equal to 0 or this stuff is equal to 0. Okay, so let us write alpha plus 1 is equal to 0, or this stuff alpha square minus alpha plus 1 is equal to 0. If alpha plus 1 is equal to 0, that means alpha is equal to minus 1. Okay, if this stuff is equal to 0, then this is a quadratic function. We can use the quadratic formula to get the value of alpha here. And what is the quadratic formula? Let's write here. The coefficient of alpha is here 1, so a, let us say we have b is minus 1, a is equal to 1, and c, in place of c we have 1. Using the quadratic formula, that means alpha will be equal to minus b plus minus b square minus 4ac divided by 2a. Okay, so what is our minus, what is b? B is equal to minus 1, so we have minus, then we have minus 1 plus minus b square means minus 1 square minus 4, value of a is 1 and c is also equal to 1, so we have like this, then twice a, that means 2 into 1. So this comes out to be minus minus is plus, we get 1 plus minus, minus 1 square is 1, minus 4 upon 2, which implies we have 1 plus 1 minus 4 is under root 3, minus under root 3 upon 2, or we have another value, that is 1 minus minus 3 upon 2. Okay, so here we can write it 1, since we have minus under root, this can be written like this. We have iota here, under root 3 upon 2, and here we have 1 minus, so we have iota under root 3 upon 2. Okay, so we got three values for alpha. Alpha is equal to minus 1, and alpha is equal to this stuff. Okay, and alpha is equal to this stuff. We got three values for alpha. Okay, here you can see these are the imaginary values here, and we only get one real what you call real value for the alpha. That means the answer to this question should be equal to minus 1, because we are being told the answer should be an integer. Only this very alpha is equal to minus 1 is integer. These are the imaginary numbers here. Okay, so how do we write this minus iota? We know that minus under root 3 can be written like this, minus 1 into 3, so we have under root minus 1 into under root 3, and under root minus 1 is always equal to iota under root 3. Okay, so we got the value of alpha is equal to -1. Okay, another point that I want to make here is that the determinant of these matrices should be equal to 0. How do we find out these determinants? Sorry, these matrices. It is simple. So let me show you how what is our A1. A1 is our special matrix which is formed by replacing the first column of this coefficient matrix with the vector of constant terms. So in place of alpha 1 0 we write 0 0 1. That means we have 0 0 0, then we have 0 alpha 1 0 alpha 1, then we have 1 0 alpha. If you want to take the determinant, it will be also equal to 0. Similarly, A2 is our another special matrix which is formed by replacing second column of this coefficient matrix with the vector of constant terms. So we have alpha 1 0 alpha 1 0. In place of 0 alpha 1 we have 0 0 0 0 0 0, and this stuff remains same 1 0 alpha. Okay, similarly its determinant will be also equal to 0, and our A3 is equal to, now the A3, this matrix is formed by replacing third column of this coefficient matrix with the vector of constant terms. So we have alpha 1 0 as it is, alpha 1 0, then we have 0 alpha 1, and in place of 1 0 alpha we replace it by the vector of constant terms which is 0 0 0. If you take the determinant of these elements, these matrices, it will be equal to 0. Okay, so the system of equations will have infinite solution if our coefficient matrix, the determinant of the coefficient matrix is 0, and the determinant of these special matrices is also equal to 0. If any of these matrices has non-zero determinant, in this case we would have no solution. Let us say if the determinant of this A1 came out to be a non-zero number, then we could have said the system of equations would have what we call no solution. Okay, when coefficient matrix, the determinant of the coefficient matrix is 0 and the determinant of the special matrix is also 0, then we say the system of equations has infinite solution. So the value of alpha is -1.